Hello class, today we're going to be looking at properties of matter. We've already covered states of matter and looking at how objects go from one state of matter to another and looking at the particles of matter and how they move and keep in motion no matter what state of matter they're in. Today we're going to look at properties, physical and chemical properties. So physical properties should be somewhat familiar to you. They're any characteristic that you can observe and you aren't changing the substance in that observation. It's easily observable or measurable. So some examples would be shape, size, color, mass, volume, density, temperature, melting point, boiling point. And the key one on here as well that a lot of people often confused to be maybe a chemical property is state of matter. So whether it's in a solid, liquid, or gas form is also just a physical property. That's something you're observing. Some other things that are measurable, making sure mass, volume, calculating density, measuring temperature, all of those things are physical properties. You didn't change anything about it. You're just simply looking at the object, measuring the object, getting as much detail about the object. Some examples then of physical properties are listed here to show you as well. There's a couple on here that we didn't mention. Malleability seems to always show up on something like OGT or something like that. And malleability is just how easily you can form that solid into another shape. So can you hammer it into another shape, form maybe an art project or something like that, like you're able to form it into something else. Another one is viscosity, and a lot of people have mentioned this in class lately, but viscosity is just how easily an object can flow. So for example, if you have syrup, that's going to flow slower or be more viscous compared to water or some other liquid that's easy to flow, that's easy to pour. Okay, so those two terms, make sure you look back over those. The others on there, I believe that we've already all mentioned. Chemical properties, on the other hand, are substances or characteristics of a substance that show how it can change chemically. In a chemical property, we are not actually changing it. We are just describing how it could be changed. So these are not as easy to observe because you're not actually physically doing it. You're just looking at the object and determining what type of physical properties it might have. Most of these you may know already, so whether something's flammable, if we have paper sitting here, you could describe it as being flammable or able to be flammable. Whether something can react, like steel combined with oxygen, will lead to rust. And so you're just explaining what can happen, you're not actually physically doing it. Now when we get into changes, we are actually going to change the substance. So in this first one, a physical change is a change in the form of matter, but not in its chemical identity. It is still the exact same chemical. It has the same chemical properties, no matter what you have done to it physically. So some examples: dissolution of salt, which is taking it out of solution, maybe evaporating water off. Distillation would be that example as well, just taking it where you're getting the pure water form. If you take a pencil and break it in two, it's still a pencil. It still works as a pencil. It has all the chemical properties that the original pencil had. It's just now two pencils. Cutting your hair. Those are examples of physical changes. We have changed something about the physical property, but we have not changed the chemistry. If we go from one state of matter to another, that is also a physical change. So basically, physical changes will help us to separate mixtures. If we have a mixture in front of us, we can go through physical properties and help to separate it out. Like whether something floats and something else sinks, we could separate those two things out based on physical properties. Chemical changes actually physically change the chemical makeup of the particular substance. So it is a chemical reaction, which we're going to get to chemical reactions even more in chapter 6, and we'll talk about what those are a little bit more. But in this case, we are transforming our original substance into something new. And so in this case, we cannot reverse it by a physical means. We can't just dissolve it and all of a sudden we're going to have something different. In this case, you'd actually have to have another chemical reaction to possibly take it back to its original form. And a lot of times we can't take these back to their original form. So examples are rusting of iron, Once that process of rusting happens, we have we have chemically changed the substance of iron into something new. Digesting food. So once you take in food, it goes into your stomach, and that process of digestion happens where particles are taken out. There's a chemical reaction where you're getting different nutrients and things out to the bloodstream and breaking it down. Rotting fruit is an example. Rusting steel, burning gasoline. So notice these terms here: rusting, digesting, rotting, burning. Those are all chemical change words. Okay, in chemical changes, we can detect that they are happening by a few physical observations, and a change in odor or color would be a good way to note that chemical changes are happening. Another thing is that we end up with a new substance and it has new properties. So this is another key part to a chemical change. Once we have those new properties, we now have something new. An example would be baking a cake. We can take all the individual ingredients: flour, vanilla, sugar, salt, brown sugar, whatever it might be that you're putting in there. They all have their own properties. If you taste flour by itself, not great. You taste an egg by itself, not great. You taste vanilla by itself, it's not a great taste. But you put it all together, you go through the chemical change of putting it into the oven and allowing it to bake, and when it comes out, it's a wonderful product. You get something new that tastes really good. Okay, and the last thing we're going to look at today is, in a chemical change, we have something called the law of conservation of mass. Matter cannot be created or destroyed in a chemical change. So whatever you start with as matter or mass is going to be what you end up with as well. Sometimes this is hard to measure or hard to gauge. If we have a chemical reaction of baking soda and vinegar, it will bubble up and it releases a gas. It releases carbon dioxide. And when this happens, if you were to weigh it before and after, you might think that you have actually lost mass from what we had at the beginning. But actually, some of that mass was in a gas form. So you have to trap that mass in order to be able to measure mass before and mass after and see that there's actually a conservation of all mass. This can be done maybe if you put it in a covered container, or maybe you put it in a balloon or something like that. You allow that gas to expand, but you've trapped it so that you can measure before and after. You can mass that out before and after and see that it has not actually lost any mass. So in a chemical change, the mass at the beginning equals the mass at the end. Okay, and that is the properties of matter that we're covering today. We will review over these on another lesson.